So I have three tables in the lakehouse that you see on the screen here. So for every lakehouse, I created individual get methods to fetch the data from the respective lakehouse. I've developed this as an Azure function, so you can deploy this as an Azure function or convert them to an API and deploy it as an Azure API. So in this video, I'll give a brief walkthrough on the code and how the code calls different methods and exposes the data from the underlying lakehouse tables. So we'll debug to the method that fetches the data from the trip underscore data table here. So I'll send the HTTP request to the browser and the process will return the data back to the browser. So during the process of this debug, it's very much possible that the process might get timed out. So if that happens, what I'll do is that I'll rerun the process all over again without the without the debug breakpoints. Okay, so this is the project. Okay, so start running the project. Okay, so this is the method for fetching the data from the trip underscore data table, and it has two parameters. First is the vendor ID and trip distance. So we are querying the data for vendor ID and trip distance, and these are the three methods. One is the category data that fetches the data from category data table. Second is the NYC taxi data, and third is the trip data. So I have this URL already ready. So I'll be fetching the data for vendor ID equal to 2 and trip distance is equal to 5. So I'll just paste that in the browser. So the next thing is going to do is that it's going to prompt for a browser-based authentication to validate your the lakehouse credentials. So this is the read config file. So read config file basically reads the data from the config settings. So we have like service principal ID, the workspace name, and the lakehouse name. Right, and then it says the value for the vendor ID and the trip distance properties. So we have the vendor ID 2 and trip distance equal to. So these are the class. This is the class that I created for table trip data table. So I created individual classes for all the tables that exist in the lake house. So next thing that it's do is that it's just gonna loop through all uh, the structure that exists under the table. So it has prompted for the browser based credentials to generate the bearer token. So once that is done, okay, so it's gonna loop through all the structure that exists uh, under the table. So as we are not interested in the delta underscore log table, so we're just gonna skip the delta underscore log table, and this is gonna return us the list of the objects that exist in the objects in the sense there exist a list of the folders and files that exist in the table under the table. So we have delta underscore log table, which is a directory, and we have the Parquet file. All right, so we are not interested in delta underscore log table. So the process, this for each loop has skipped the delta underscore log table and will be reading the file, the Parquet file. So all this thing is happening through the ADLA Gen 2 API. So now we are gonna fetch send a request to get the attributes of the Parquet file. So now we have it has returned all the attributes for the Parquet file. So as you can see, so we have the file name, the creation time, and the permissions. Now, what we'll do is that we'll skip this intermediary step and we'll just send a request to get the data for not the data to fetch all the underlying objects of the Parquet file. So basically, this table trip underscore data is approximately 3 million rows. So it's going to fetch a response for all the 3 million rows. Okay, so we have the response for this table uh, uh, trip underscore data. Now this response acts as an input for the read Parquet file method, and read Parquet file method utilizes Parquet.net library. And this read Parquet file method expects parameter in form of a stream. So we are sending this response as a stream to this method. Okay, and this Parquet reader basically would read all the properties of the Parquet file. So it returns returns the number of row groups and number of I'll just show it to you here. So it returns the number of row groups and the schema and like other things like the versions and all the metadata. So it's very much possible that your data that you have queried is spread across multiple row groups. So we do not want to skip all those data that is spread across multiple row groups. So what I'm doing here is I'm looping through all the row groups that exist in the Parquet file, and then whatever data we get for that individual row group is then added to the trip filtered list. So for example, if this row group has two row groups, sorry, this Parquet file has two row groups. So basically, this for loop would loop across all these row groups and add the data that exists in the row group into this trip filter data list. So I think this has this file has only one row group. Okay, so we are, yeah. So now this stream is then deserialized using Parquet serializer class in the Parquet.net library, and I'll just run this. So basically, this method is deserializing almost 3 million rows, and then you're using linkcube method type. I'm filtering the data from this 3 million rows. So if you look here, the it has almost 3 million rows, right? And thus I am filtering out the vendor ID, which is 2, and the trip distance is equal to 5. Now we'll see the number of rows that are filtered. So we have 677 rows. So the qualifying rows for this value of vendor ID and trip distance is almost 677 rows from the 3 million rows. It will then move on to the next row group. So since there's only one row group, so it will exit the for loop. Now this output that we get the list object, right? So we have now we have the data in a list object. So this list object will be then serialized and sent it as an JSON to the browser. I hope it has not timed out. Okay, it has. Okay, it has timed out. Okay, and we don't have an output here. Okay, no worries. So what I'll do is I'll just quickly disable all the breakpoints and rerun the entire process again. So again, it's gonna go through the same steps. It's gonna prompt for a browser-based authentication, and then we are gonna put the URL with the required parameters. So I'm not running this process on a very fast machine. So it has almost this machine has almost like 12 gigs of RAM. So so it's expected that there will be some kind of a latency. So if you run it on a much faster machine and a faster internet, so definitely the entire process would have a tremendous response time. Okay, I need to, okay, it's prompt time for the authentication. So let me do one thing. I'll just add a breakpoint here so that we'll know that we are at the endpoint, reach the endpoint of the process. And the process can also be improved by using some kind of a cache. Like for example, if you implement an Redis cache on Azure, so it's very much possible that the process would response will improve because each time what is happening is that it's fetching the data from the response from the object itself. Okay, now we have an we finished the process, and we should have an output in the browser. Yep. Yep. Now we have the output in the browser. So this time it did not error out, and also we have this succeeded message. So it almost took 66 seconds, right? If my math is not wrong, so it almost took little over 66 seconds for creating the response and returning the reading the data, deserializing 3 million rows and filtering the data based on the parameters that we have sent. So entire process took almost 66 seconds right from the time we uh, completed the authentication. Okay, so we started the entire authenticate. I think we should count from, yeah, from here, right? I'm not sure. I think this is the process. I'm not sure. It took like 60 a minute, right? Okay, 66,000 milliseconds. Sorry, let me do a quick. Okay, I think it took almost like 66 milliseconds, 2 seconds. So it took almost 66,000. No, almost took like a minute. Okay, all right. So that's all for this walkthrough. I hope I was able to explain at a very high level. So what are the underlying methods that needs to be called, and what are the different artifacts that are involved in the entire process. So let me repeat again. So this process was not run on a very fast machine, and if you have a machine that is much more having a very high configuration, the process would definitely run faster. And on top of that, if there is some kind of a cache mechanism, so we can definitely improve the overall process speed of the process. All right. Okay. Thank you very much.